All right. Let's go back to finding that equation of the tangent line again. Remember, what does the equation of the tangent line again mean? Derivative, because that's how you get your slope, right? As soon as you see that tangent, you know you're taking a derivative because you have to have that for the slope. Okay, find an oh my, I didn't mean to do that. Find an equation of the tangent line to the curve. This curve, x's and y's in there, so what kind of process are we going to use? Implicit, good, implicit differentiation at this special point. Alrighty then, let's do it. X squared plus xy minus y cubed equals 7. We're taking the derivative with respect to y. What's happening with this middle term? They are multiplied. So you definitely get to do the product rule. Good. So let's do it upright. The derivative of x squared is 2x plus my product rule. So we have the derivative of the first times the second plus the first times the derivative of the second. And remember, the derivative of y here is dy dx minus, and then you're going to take the derivative of this last term like normal. So 3y squared, but because it's a y, what are you putting there? Dy dx. Nice. Dy dx. And then the derivative of a constant is 0. So the same thing again, we want to isolate the dy dx, and these two terms have the dy dx in them. So we're going to subtract off the 2x and the y. And we end up with x dy dx minus a 3y squared dy dx, oops, almost missed the d, is equal to a negative 2x minus y. I'm going to scoot it up a little bit. Factor out that dy dx. X minus a 3y squared is equal to a negative 2x minus y. Divide both sides by an x minus 3y squared. Because it's factored and it's multiplied, right? We've done this process already, so we're going to keep it up. Then you just know dy dx is equal to a negative 2x minus y over x minus a 3y squared. That is my generic slope. That is the word generic. Contrary to what it may look like. Right? That's my generic slope. The slope of a tangent line. So any tangent line on that curve can be represented by that slope. Then I just look and say, oh yeah, right. What's my specific point? It's 3, 2. We plug it in, don't we? All right. We have x's and y's. No sweat. I'm going to put this here, 3, 2. I'm going to scoot it up so we can see it a little bit bigger so it's not so small on your screen. So I'm going to evaluate my slope at, or my derivative at 3, 2 to get that slope. So I've got negative 2 times 3 minus 2 over 3 minus 3 times 2 squared. Do you see that? So I've got negative 6 minus 2 is a negative 8. 3 minus, and this is 4 times 3, so that's 12. So 3 minus 12, negative 9, good. A negative divided by a negative is a positive 8/9 for my slope. Then I've got my point 3, 2 with my slope, and we algebra. Y minus 2 is equal to an 8/9 x minus 3. We can distribute. So y minus 2 is an 8/9 x. This we can simplify a little bit, right? That 3 takes that out. And we have 8/3. We want to make our life easy. So add 2. When you add 2, you need to get that common denominator. I'm scoot it up a little. So it's a common denominator of 3. So that gives me a 6/3. 8/9 x minus a 2/3. And that's the equation of the line, my tangent line of that curve at the point 3, 2. Not too bad, right? Sure. It's just that process, right? Basically, you're just taking derivatives like you've taken derivatives up to this point, but anytime y is involved with a derivative, you tack a dy dx on it. That's the moral of the story. It's not bad. Yeah. Do